This is San Francisco Geology by Kyle and Ethan. So there are many types of rocks in San Francisco. You have greywacke, chert, sandstone, granite, basalt, and serpentine. These rocks are spread all across the Bay Area. So first up, you have greywacke. It is a sedimentary rock, and as you can see, it is formed underwater through these kind of vein-like structures that go across the seafloor. Then there's chert. Chert is a sedimentary rock that is very easily to break apart because it is formed of piles of sediments that are separated by layers of clay and then compressed together. Sandstone is created from pressure, and it's usually in the ocean because the water and the loose sands compress the sands at the bottom to harden them into sandstone.
Granite is an intrusive igneous rock, and it is formed in lava pockets of volcanoes where it cools very slowly, and that gives it its large crystals. Basalt is an extrusive igneous rock, and it forms very small crystals because it cools very quickly, because it comes out of the volcano and it forms in air or underwater. Serpentine is a metamorphic form of basalt, and it is when it absorbs a lot of water and the structure is destroyed, so it falls apart very easily.
So this is a geologic timeline of California. So 350 million years ago, the North American continent collides with the ocean floor in what is known as the Antler Mountain building event. So the crashing heated rocks on the coast so that it crystallized them and turned them into metamorphic rocks. These rocks compose the Shoe Fly complex, and it now forms most of the eastern Sierra Nevada.
200 million years ago, the Farallon Plate begins to subduct under North America.
175 million years ago, the Mesozoic plate collided with the North American plate and caused basalt, chert, and greywacke to come to the Bay Area.
130 to 145 million years ago, deep underground granite was solidified after being put there from accretion to start to form the Sierra Nevada, although the mountains only uplifted about 4 million years ago to form what we see now.
100 to 200 million years ago, a subduction trench off the coast of California formed the Franciscan complex.
28 million years ago, the San Andreas Fault formed. As you can see here, serpentine forms the northwest side of San Francisco, greywacke forms the northeast. Greenstone, greywacke, and chert can be found towards the middle, and there's a melange belt in the south.
So this is a cross section of San Francisco. As you can see, we cut a diagonal line from the southwest to the northeast side of San Francisco. This line runs through 5 different points, and we're going to show you what it looks like on the inside of San Francisco, the layers. So the first layer is composed of greywacke, the second and third are composed of melange, the fourth is serpentine, and the fifth is greywacke. So the line that we cut along San Francisco went along 5 sections of terrain. Each terrain is on a different dip. Most go northwest to northeast, but at the far northeast corner of San Francisco, the dip goes south, which makes point 5 a fold point. Each of the points are composed of a different type of rock because they are in different areas that have different rock types that got there from trenches and subduction. As you can see, there are points of reference between each different point. Point 1 is near Lake Merced, point 2 is near the San Francisco City College, point 3 and 4 are near the New Mint, and point 5 is near Nob Hill in the Presidio. So now we're going to show you a little tour of the Bay Area in Google Earth. So this is a view of San Francisco, all the places that have obvious rock spotting spots.
This is Kehoe Beach, and you can see a little towards the right that there's an obvious split in the sandstone wall, and that is because of a normal fault where one side is falling down and the other one is staying up.
Next up, we're traveling over to Point Bonita. Down here we saw some pillow basalt. And pillow basalt is basically just regular basalt, except it comes out in pillows, which is just soft, smooth, and very round.
Next up, we are at Billy Goat Hill, where we saw Greywacke and Chert, and here you can see people measuring the dip and incline of the chert.
Next, we go over to Fort Mason. Down there, we saw some Greywacke and we sketched it in our notebooks.
And this is also the first time that we got to taste Greywacke. Now up is Hawk Hill, and this was where we saw Chert. This was also the first place we got to identify a rock by a taste test, which was an experience to say the least.
Then, when we were driving around in Point Reyes, we stopped at a granite outcrop. As you can see, it's kind of crumbling apart and it's very loose in between.
It also has that color because of the iron that oxidized inside it. Here at Marshall Beach, we see a vein of serpentine in a piece of pillow basalt. And there was also clay that was made of serpentine, so it had like a light mint green color. That was cool.
Then, as we were on our way to our Point Reyes overnight trip, we stopped at this giant wall of pillow basalt. You can see here that there's just a bunch of basalt and it looks like it's just rolling down in pillows, actually.
Here's Twin Peaks, where we saw Chert, and we didn't really do much with it. We were at Twin Peaks to try to identify different parts of San Francisco, not look at the rocks that were there.
But we happened to find some chert with some very distinct layers. Then, after we went to Twin Peaks, we went down to a park and saw what is called a slick and slide.
Which is where the rocks melt a little bit and then the plates move and it gives it this really smooth, almost marbled texture.